Hey, good morning or good afternoon, depending on when you're listening to this. Just a quick note before we jump into today's podcast. The Cosmosphere's Everything Under the Stars event is coming up really soon. So if you're going to be in Kansas, I would love if you could come out to Everything Under the Stars and join everyone there for a night of fun. I will be linking to details in the show notes. So if you're in the Kansas area, come on out. I'd love to see you. Say hi. I'll have some Space Shot stickers. So if you're in the neighborhood, just let me know. And now, let's get to the show.
All right, liftoff and the clock has started.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Houston, Tranquility Base here. The Eagle has landed.
Discovery, go at throttle up.
And liftoff, the final liftoff of Atlantis on the shoulders of the space shuttle. America will continue the dream.
This is The Space Shot, episode 397, this week in space history for October 14th to the 20th. I'm John Molnix. Before we get started with today's show, I want to make sure that everyone knows that there's a call-in number for the podcast. You can call or text with questions or comments. Just hit me up at 720-772-7988. Just leave a message and I'll be sure to get back to you. Now, it's time to break the sound barrier. On October 14th, 1947, Chuck Yeager broke the sound barrier while piloting Glamorous Glennis, an experimental Bell X-1 aircraft. The Bell X-1 was a rocket-powered research aircraft designed by the Bell Aircraft Corporation in the 1940s. There were several variants of this aircraft, the X-1A, B, C, D, and E, which flew from the late 1940s to the late 1950s. NASA notes that not only was the X-1 important because it was the first aircraft to break the sound barrier, it's also important because these planes, quote, established the concept of research aircraft built solely for experimental purposes and unhampered by any military or commercial requirements. Although subsequent X-planes were built for a wide range of purposes, technology or concept demonstrators, unmanned test missiles, and even as prototypes, in all but name, the X-1s were built to go faster than an aircraft had ever flown before. I'm linking to a NASA fact sheet on the X-1 in the show notes. Be sure to check it out. Before his historic supersonic flight, Yeager flew fighters during World War II, becoming an ace and decorated pilot. Next up, let's head to Saturn. The Cassini spacecraft launched on October 15th, 1997 on a Titan 4B rocket. Cassini's launch was the only time that a Titan IV rocket was used to launch a scientific payload. All other launches with that vehicle had been for the military or intelligence agencies. After launching from Earth, Cassini performed numerous gravity assist maneuvers, twice at Venus, once at Earth, and one finally at Jupiter. The spacecraft arrived at Saturn after a 6-year, 261-day cruise, and it started investigating this beautiful planet and its moons. Cassini's prime mission began in 2004 and lasted until 2008. The first mission extension was from 2008 to 2010, which was the Equinox mission. The final extension, or the Solstice mission, lasted from 2010 until September of 2017. I wrote a piece about Cassini that's available on medium.com, and I'm linking to it in the show notes. Be sure to check it out. Now we're going to talk about the weather. Thankfully, this isn't some awkward small talk segment where I go on about Colorado's bizarre weather, although we did have a 70-degree temperature swing last week. I actually want to talk about Earth's weather more generally, specifically the GOES-1 satellite that was designed to study weather from space. On October 16, 1975, GOES-1, or the Geostationary Operational Environmental Satellite, launched to study the weather of Earth. The GOES series of satellites are a joint effort between NOAA and NASA. According to NASA, quote, these spacecraft help meteorologists observe and predict local weather events, including thunderstorms, tornadoes, fog, hurricanes, flash floods, and other severe weather. In addition, GOES observations have proven helpful in monitoring dust storms, volcanic eruptions, and forest fires. There's a fantastic website that has all of the GOES imagery, and it's continually updated. I'll be sure to link to that in the show notes. Do check it out. There are some great pictures of our home planet. The GOES project was a development of the earlier Applications Technology satellites and the synchronous meteorological satellites that launched during the mid-1960s to mid-1970s. In the nearly half-century since the GOES program started, there have been more advanced satellites brought online. Initial satellites in the series like GOES 1, 2, and 3 were spin-stabilized, like the synchronous meteorological satellites before them. Spin stabilization meant that a spacecraft didn't need to expend fuel for station keeping. The spacecraft would spin around like a top if you had spun one on the table. 3-axis stabilization is another way that spacecraft are controlled. Newer GOES satellites are stabilized in this way since it allows for precise orientation of the satellite for science objectives. Expanding our knowledge of Earth science is part of NASA's Earth Science Division. This division coordinates both airborne and satellite observations to help us understand our world. Working towards bettering our knowledge of the weather here on Earth isn't done strictly for scientific reasons. There's also an economic imperative as well. Think about how many industries are affected by the weather. Farming, ranching, fishing, air travel, anyone that has to drive in inclement weather, tourism, and countless others are all affected by the weather here on Earth. It's incredible that studying the weather from space has taken place for nearly a half-century now, and I don't think we should shy away from finding out as much as we can about our home planet. It's both economically and scientifically prudent to do so. Next up, we're headed to another gas giant. The Galileo spacecraft launched on October 18, 1989, during the STS-34 mission with the Space Shuttle Atlantis. The crew of Atlantis deployed the Galileo spacecraft just a few hours into their mission. Galileo spent 6 years getting to Jupiter due to a couple of reasons. NASA notes that, quote, the Galileo mission had originally been designed for a direct flight of about 3.5 years to Jupiter using a planetary 3-stage inertial upper stage. When this 3-stage inertial upper stage was canceled, plans were changed to use a liquid fuel Centaur upper stage. Due to safety concerns after the Challenger accident, NASA canceled the use of the Centaur on the space shuttle, and Galileo was moved to the 2-stage inertial upper stage. This, however, made it impossible for the spacecraft to fly directly to Jupiter. To save the project, Galileo engineers designed a new and remarkable 6-year interplanetary flight path using planetary gravity assists. With the upper stage selected and the shuttle finally launched, Galileo was on its way to Jupiter via an indirect path that many missions to the outer planets must take. The Galileo spacecraft was able to perform important science during its cruise to Jupiter. The spacecraft completed a flyby of Venus, passing within about 10,000 miles of the surface of that planet. It then continued back to Earth, flying within 597 miles of our planet on February 10, 1990. Finally, there was another Earth flyby on December 8, 1992, and Galileo came within 188 miles of our planet. During the cruise to Jupiter, it was discovered that the high-gain umbrella-like antenna that was on top of the Galileo spacecraft wouldn't properly deploy. The high-gain antenna would have allowed for faster data rates for the information that was being sent back to ground stations that are part of NASA's Deep Space Network. Thankfully, ground controllers were still able to use the low-gain antennas to accomplish most of the mission objectives. On October 29, 1991, the Galileo spacecraft became the, quote, first spacecraft to encounter an asteroid passing within 1,000 miles of Gaspra. 2 years later, on August 28, 1993, it flew by a second larger asteroid named Ida. It was discovered that Ida had a small moon, later named Dactyl, which is less than a mile wide. The mission continued to bring back incredible science when the spacecraft team instructed Galileo to collect data on the impact of comet Shoemaker-Levy 9 into Jupiter. I'm linking to these images in the show notes as they are truly spectacular. The speed that the cometary fragments were traveling at when they impacted Jupiter meant that there were massive amounts of energy released in the ensuing collision. One of these fragments impacted Jupiter with the energy equivalent of 6 million megatons of TNT. This is hundreds of times as much power as all of the nuclear weapons on Earth put together. Now we've got some more recent space history. An Ariane 5 rocket successfully launched the BepiColombo mission on October 20th, 2018. This mission is a joint ESA and JAXA venture to Mercury, the closest planet to our Sun. It was a beautiful night launch and a perfect way to mark the first time the Europeans have led a mission to Mercury. There are 2 spacecraft that launched on the BepiColombo mission, and they'll study Mercury simultaneously. Science returns won't start to roll in until 2026, which underscores how difficult it is to get closer to the Sun. It's counterintuitive, but a spacecraft requires more energy to reach Mercury than Pluto. After 7 years of constant braking with an ion engine, BepiColombo will arrive in orbit around Mercury. At this point, the spacecraft will pick up where the NASA Messenger mission left off, studying everything from the exosphere to volcanic activity. The 2 orbiters, the Mercury Planetary Orbiter and the Mercury Magnetosphere Orbiter, will remain attached until October of 2025. Before the arrival at Mercury, BepiColombo will perform 9 planetary flybys, 6 of which will be at Mercury. The spacecraft will fly within roughly 125 miles of that planet during these maneuvers. These gravity-assist flybys will complement the solar electric ion thrusters, helping to guide the spacecraft into a stable orbit. BepiColombo will travel 9 billion kilometers, or nearly 5.6 billion miles, and will reach a top speed of 60 kilometers a second. That's a blistering 134,216 miles per hour during its 7-year journey to Mercury. Here's to a successful cruise portion of the mission and to incredible science that we can expect to come back to Earth in 2026. Lastly for today, we've got 6 scrubs and a launch. The 7th time was the charm for the crew of STS-73 when the Space Shuttle Columbia finally lifted off from Pad 39B on October 20th, 1995. This was the 2nd flight of the U.S. Microgravity Laboratory Space Lab mission, and during this 16-day trip, the crew split into a red and blue shift to work around the clock in this science laboratory. Dividing into 2 teams meant that 12-hour shifts could be utilized, maximizing the time spent doing experiments on orbit. During this mission, astronaut Kent Rominger, a Colorado Potato Country native, was excited because he was tasked with growing potatoes during the flight. Specifically, the crew was investigating how to deliver water and nutrients to plants growing in space. For fans of The Martian, I think Mark Watney would be proud. That's it for this week. Be sure to subscribe to The Space Shot so you never miss an episode. I'd love it if you could leave a review on Apple Podcasts. They help more people find out about the show. I've got a number that you can call or text with questions or comments. Hit me up at 720-772-7988 and leave me a message. I'll be sure to get back to you. You can also connect with me at John Molnix on Instagram, Twitter, and Facebook. All the social media links are in the show notes. Until next time, I'm John Molnix, and I'll catch you on the flip side.